Hello, and welcome back to California Geology. I am Dr. Robert Lopez. Today I want to talk a little bit more about deserts. Two features of the deserts that I want to talk about. One is this desert varnish, and the other one over here is going to be a desert pavement. Looking at the desert varnish, what it is, it's an iron and manganese staining on the rocks. It's a dark staining or coating that occurs on the rocks, and it seems to occur primarily in arid, dry environments, kind of these extreme, more dry environments. And what it seems to be a biochemical weathering product of these bacteria-like organisms called archaea. And archaea are also known as extremophiles because they love to live in extreme environments. You'll find them at mid-oceanic ridges, at hot springs, in glaciers. You'll find them in deserts. Now, one of the strange things about this desert varnish is this manganese, and we call it here the manganese anomaly, because in soils and in rocks up on our surface up here, the ratio of manganese to iron is 1 to 60. So in other words, there's 60 more iron atoms per every manganese atom. However, when you look at the varnish itself, the ratio is either 1 to 1, or it can be as much as 50 manganese atoms to every 1 iron atom. So where is all this manganese coming from? And it seems to be a process performed by these bacteria archaea who prefer this manganese. And I'll show you some images of that in a moment. And then the second feature I was going to talk about here is desert pavement. And desert pavement is an armor of gravel that mantles the desert surface. And if you were to remove that desert pavement, you'd expose a finer, light-colored silt underneath it. And we'll talk about some of the ways this desert pavement could form. Now, for the desert varnish, note that it's this dark manganese and iron staining on the rock, a dark coating, and produced by this bacteria. And then in this image here, Native Americans would etch away on that desert varnish, exposing the lighter colored rock beneath it, and those drawings are called petroglyphs. So a petroglyph is a Native American rock drawing made by chipping off the desert varnish. Now, this is a close-up using an electron microscope of some of that varnish, and one of the features we find is that the varnish occurs in these layers, these thin layers, and remember 20 micrometers. Remember, there's about 1,000 micrometers in 1 millimeter. So this is very small, right? So we're getting really close here. And what we find is that in the layers, there are bacteria and also the varnish, but we find that the bacteria have a very high concentration in manganese and iron. So the bacteria are preferentially processing that element, which leads to this varnish. So that'll explain our anomaly, and it leads more criteria to suggest that the varnish is being produced by this biochemical weathering product. Now, when we look at desert pavement, here this is a class, a West Valley class from years ago, where we're out here in the Mojave Desert, and we're looking at this this gravel, this armor of gravel that coats the desert floor. There's very little silt or sand, and here's a close-up showing this gravel. And note that it's pretty well placed. It's almost like a mosaic where it's well oriented. And so there's a couple of Native American drawings that are also made dealing with the desert pavement. In this case, they're called intaglios. And an intaglio is a large-scale markings made by Native Americans by scraping away the desert pavement. And remember, the silt is exposed beneath there, so you expose that silt. Here, these bushes are probably maybe 5 or 6 feet in diameter. So these are good 45 to 50 feet tall. So it's a large-scale drawing here. These intaglios are near Blythe, California, which is on the Colorado River. Now, here's another one showing, I like this one, it's a fisherman. There's the water here, there's some fish in the creek, there's a bird flying above here, and there's the sun there. So, again, a very large scale feature here. Now, couple of ideas in terms of how the desert pavement may form. One is called deflation, and your book talks about deflation in that wind speeds in these environments can get quite high, and since there's very little vegetation, there's little to hold down the sand, so the sand can get picked up to as much as 2 meters above the ground. And if you're ever driven through a sandstorm, it's going to it could abrade your car, your windshield. But in that process, it seems to be that the wind is blowing away the finer sand and silt particles, leaving the coarser gravel behind. And that gravel sits upon other silt and sand, which it protects. So it prevents that gravel or the silt underneath from being blown away. So that's one method you can form it, this deflation. Another method is recent studies have looked at taking beetles and maybe some mice and rodents, kangaroo rats. Here the desert tortoise is a desert tortoise. I took a picture of this back last fall. We were camping near Barstow, and here was this desert tortoise walking around, moving these rocks around. So the idea is, as the beetles, the rodents, the desert animals walk around on this gravel, they're shifting the gravel where silt and sand gets tucked underneath. And one experiment done at UC Santa Cruz had some of these beetles walking around in a terrarium with gravel and sand and silt, and over a period of time, there was a desert pavement being developed. So that's an idea. Although the more the deflation seems to be the more popular idea for forming these desert pavements. But one thing about them, they do take hundreds to thousands of years to form. Now, sand. When people think of desert, they think of sand dunes and wind blowing. But in reality, sand dunes make up a small percentage of the desert. For example, in Death Valley, the sand dunes only cover 2%, only 2% of the valley. So, but where they do, they can pile up to great heights. In fact, these are the sand dunes over at Stovepipe Wells. They can be up to 300. In fact, the Kelso Dunes over in the Mojave Desert are up to 600 feet tall, 200 meters. So they can get quite large. It's great heaps of sand blown up by the wind action. And your book mentions that there are three criteria to make sand dunes. One is you need wind speed. So high enough speeds of wind to transport those sand grains. The second one, you need little vegetation. So once you get vegetation growing on the surface, you're going to anchor that sand down, and you will not have a source of sand. And finally, the third one is you need sand-sized sediment. And so again, so the wind speed, little vegetation, and sand-sized sediment. So when we look at the Stovepipe Wells, right here, Stovepipe Wells and the sand dunes that occur in Death Valley here, the criteria I met here, we have the Emigrant Pass, which is coming over here from the west in the Pavement Valley. Wind speeds can be channelized through these wind gaps, and the wind speeds can get quite fast. They'll come down this Cottonwood Canyon and blow across this alluvial fan. It's kind of fan-shaped pile of sediment. And then that sand gets picked up and deposited on the other side of the valley, forming these dunes. Now, even though it rains very little, 3 centimeters per year in Death Valley, when it does rain, water is probably the most important agent of sculpting and shaping the landscape, because as soon as that water starts moving and there's no vegetation, it's going to do its erosion, transportation of material. It's going to carve these canyons, and one hazard in the desert are these flash floods. And here are some slot canyons. And what I want you to know in this picture here, the desert Varnish is here. And I always ask students, well, why is the bottom part of this canyon not have desert varnish? And that's because when there are flash floods here, the water goes to this height and abrades away that varnish. So there's varnish here, but not here. So you can tell how high the water would get during a flash flood. Here's a hiker in one of these slot canyons, and we can see boulders in here. So look at these big boulders. So they're being carried by flash floods. In this case, the desert varnish is up here, and so all the varnish that was down here has been scraped away by flash floods. So again, the desert morphology, remember the shape, morph means shape. The shape of the desert is sculpted by water. And the definition of a flash flood is you have a high precipitation over a short duration of time. So high precipitation over a short duration. And it could be sunny and clear where you are, but if it's raining up in the mountains, the problem is if you're hiking around or camping in one of these washes, which you don't want to do in the desert when it's raining, is the flash floods could occur. They'll form in the mountains, and because there's little vegetation, the water will just start flowing down creeks very quickly. These arroyos, an arroyo would be a dry wash, but the arroyos will fill up with water and cause flash floods. And your book talks about several examples of some flash floods that cause quite a bit of damage. Now, three more features here on California deserts and deserts in general. This is an image looking from the Black Mountains westward across Death Valley, the Death Valley Playa, and we're looking up to Telescope Peak. So Telescope Peak would be this peak here in the Panamint Range. And what you see coming out of here, these canyons, sometimes they're called wine glass canyons because they open up to a big stem here, and there's a catchment basement up in here. So it's where narrow canyons here, there's more energy, the water will have more energy, it can carry more material, but as soon as that water enters this bigger valley here, the water loses energy and drops off its sediment. So a channel will form here. You can see these are more recent channels, but you can see older channels used to be here. So over time, these flash floods, one flood will go here, then next year maybe another one goes out here, and it goes out here. So over the years, you'll get this sort of changing drainage system, and it'll make one of these fan-shaped deposits. There's another one here. Here's another fan-shaped deposit. So an alluvial fan, it has a fan shape in map view, and it occurs where a narrow canyon opens up to a wider valley. So it's a deposit of alluvium. So remember, alluvium, if you spell it A-L-L-U-V-I-M, alluvium is sediment transported by water, right? So now the alluvial fan would be this sediment now that's the shape of this fan. Now when you get several canyons here, and the alluvial fans start to coalesce, start to kind of merge together here, then you get this nice mountain front here called a bajada. So bajada in Spanish means kind of a slope, a gentle slope. So here's our slope, or bajada. So coalescing, joined alluvial fans are called bajadas. And then the playa lake bed would be this area here. This is the dry lake bed. And there are salt deposits here, maybe mud cracks from evaporating water. One thing for sure is these playas used to have water in them, right? And some do. When there's quite a bit of flash floods, there'll be a water collecting here. So playas, bajadas, and alluvial fans. All right, well, let's stop here for now.